Types of energy chart number 2. So going on with your chart, you should be looking at the second page now, starting with biomass. So the first energy source here is biomass. Now it is renewable, but it has to grow back. So think of trees that we cut down and we burn for firewood. Those trees, that forest has to grow back. And so with pines, that may take 20 years. With oaks, that may take 70 years. If you're growing corn for ethanol, then you can grow corn usually once a year in most places. So it is renewable, but not immediately renewable. So we use biomass for a lot of different things. We cook with it in a lot of countries. So in developing countries, it is their main energy source for cooking. And remember that indoor cooking fires are the leading cause of death from indoor air pollution in developing countries, so not the US. A lot of places use them for heat, and that includes some states in the United States. My aunt and uncle use a wood-burning stove to heat their home in Idaho in the winter. In Alaska, their worst air pollution is during the winter because in Alaska, most people heat their homes using wood, and that creates a lot of particulate matter air pollution during the winter. Now, ethanol in cars comes from corn in the United States. In Brazil is sugarcane, which tells right here. And then burning trash for electricity. So the majority of our trash, which you will learn later, is actually paper and cardboard. And so when we burn paper or cardboard, which is made out of trees, that is biomass. So there's many different ways power is generated. You have combustion, which again, you should know means lighting on fire. If we are to burn the trash for electricity, it's the same process. You light it on fire, you boil water, and the steam spins the turbines. And then for ethanol cars, it would be the internal combustion engine. So some cars run on ethanol instead of gasoline. Our environmental problems. So in order to grow sugarcane in Brazil, they cut down parts of the rainforest, the Amazon. When you burn wood and even corn and things like that, these are the main. So you have particulate matter is the worst one for air pollution. You do have some carbon monoxide. And then for climate change, you have CO2. So wood is not as bad as fossil fuels in terms of the CO2 that is emitted, but it still is a problem. And then in order to grow things like corn, it takes fertilizers and pesticides. And so there are problems, again, that you should go back and review for fertilizers. Too much fertilizers cause eutrophication. Pesticides can, some of the particularly toxic ones can cause brain delays in kids, and some of them are carcinogens. Human health problems, so here's your respiratory problems such as asthma, and that really is mostly from burning wood for heat or for cooking. And again, here's our developing countries for cooking. In the US, our main biomass is corn ethanol. Now we are looking for some alternates. There are some researchers out there working with algae for ethanol instead, which is more sustainable than corn. Some people are also looking into the hemp plant, which is not marijuana. It's marijuana's cousin that does not have the THC content, so it doesn't get you high. But some researchers are looking at hemp to create ethanol out of. Switchgrass is a big one that researchers are using from the USDA. And so those are all, they're all looking for more sustainable biomass for ethanol than corn. And then you need to know that in Brazil they use sugarcane for ethanol. So solar is renewable. It is renewable every day. Every day the sun comes out, it rises and sets. And even on a cloudy day, you can still make some solar energy, but not a ton. So cloudy and rainy days don't give you a lot of energy from the sun, but it is a renewable resource. It comes every day. So a lot of times when people think of solar energy, they think of that. And those are photovoltaic cells, which we call PV cells. But there are a lot of other ways to make solar energy. Passive and active solar for heating and cooking. People do these things. So in your book, you sticky noted about these items, so make sure you know what passive and active solar is. And then now we're at PV cells. That is for electricity only. But people have been using solar energy strategically through passive and active solar for millennia, really. How you face your house, you face it towards the south, towards the equator, is going to heat up your house in the winter better. So all of those things have been used long before the technology for solar panels. And again, in our class, and the AP test is going to call them PV cells, photovoltaic cells. So with PV cells, it's the electrons that get excited in the silicon. So the sun shines down and it hits the silicon in here and it releases electrons, and so that's what electricity is. It's the flow of electrons. In passive and active, it's direct heat, and then there is another type of electricity that's made out on the way to Las Vegas, but still in California, so out in the desert. We have these solar farms that they have mirrors that reflect the sun to a big tower. And in the big tower, you have, you have all of these mirrors, and they reflect the sun. And in the tower, you have water, which boils, and then there's also a turbine in here. So there's a turbine in this tower, and the water boils, and the steam spins the turbine. Making PV cells creates some toxins, so that's a problem. With passive and active, there is no environmental problems. These type of solar electricity operations kill birds, because what happens is that the bird flies here between the ray and it gets zapped and dies immediately. No human health problems from solar. The main countries, so Germany leads in the technology, really, and they also make a lot of PV cells. China also makes a lot of PV cells, and they are leading the world in solar as well. Wind is mainly used for electricity now. Historically, it was used to grind grain for hundreds of years. You can think of Denmark, how they have all those windmills there. So the power of the wind would turn a grinding block that would take your wheat and turn it into flour. And so we also have used water wheels in the same way. So wind is probably the easiest to understand. Basically, in a windmill, you have your generator here at the top and turbines. So the windmill is basically a turbine. So these are basically turbines here that spin. In some places, birds and bats hit the blades and they die, and we already have problems with our bats from white nose syndrome, and bats are extremely important because they eat bugs. They save farmers billions of dollars each year in pesticides because the bats come out at night and eat bugs, which is great, and they can also be pollinators as well. So make sure you review that about bats too before the AP test. No human health problems with wind. So what countries lead? Well, historically, and the highest percentage of their own electricity is Denmark. Who makes the most megawatts of power? It is now China. It used to be, I believe, the US or Germany, I don't remember, but I had to change this one recently to China because now China leads in the most megawatts of power made from wind. The next one is more experimental. It does occur in a few places around the globe, but it is not very well used. So basically in the water, the wave energy or the tidal energy comes through and spins the turbines. So it is just kind of an easy mechanism out there. The problem is you have fish, you have plankton, you have migrating whales and sea turtles that can hit the blades and die, so you have the marine habitat that is disrupted. No human health problems. Which countries? You can leave that blank because there are several countries, including our own, that are experimenting. These are some other types out here. So there's a lot of experimental turbines out. Well, when I say a lot, there are several places researching, and they have them out there in the ocean, but they're not particularly common. So the next one here is geothermal. So geothermal is renewable if your groundwater is not depleted. So under the ground, you have here a water. So under the ground, there is water down here, stored in your aquifers, your groundwater. And if your groundwater happens to be, or I'm going to say it differently, if the magma happens to come really close to your groundwater, remember magma can come pretty close to the surface and actually can come out in volcanoes, right? But in some places it comes really close to the groundwater, and then the groundwater gets all hot and then the groundwater steams up. And so these places are normally called hot spring locations. Iceland is all full of this area, so their groundwater is hot and steamy. So we can actually take that hot water and we can pump it up into homes, into pipes in the walls, and it can actually heat a house through the pipes in the walls. Some places in Paris do this. We can also take this steam and we can spin turbines. And so this is a power plant that uses geothermal energy. So just the steam from underground spins turbines. There's also a newer type of thing where, you know, the ground is going to be warmer in the winter and cooler in the summer. If you've ever started digging in the earth, and if it's 100 degrees outside and you start digging down into the dirt, it's cool there. So can we use that to heat and cool our house, that temperature differential? We can. So your book talks about ground pump heat, and make sure you review that because it is a newer type of geothermal energy. So it's not using hot steam, it is using the ground's natural cooling and heating because it's different temperature than the outside air in the summer and winter. We can deplete our groundwater. Naturally in this water, there are chemicals. So the water here has some sulfur and some other corrosive chemicals. It's also noisy, so these plants here are noisy. Human health problems. So natural sulfur at these hot springs can become airborne, and we can mitigate this. So remember, the word mitigate means to fix. We can put special scrubbers on power plants to fix this problem. Iceland leads the world in geothermal. Here is a picture of ground heat pump systems. So this is not magma, this is not groundwater. This is different than that. But basically, let's say in the winter, the pump pumps cold water, cold air underneath, and the ground is naturally warm, and it warms the air, so the air goes through all these pipes and warms up, and then we pump that warm air into your home in the winter. And we do the opposite in the summer. And so that's a ground heat pump system. Hydrogen. So hydrogen is renewable, but the problem right now is that in order to get a lot of hydrogen gas, we have to do electrolysis, which is splitting water. And when we split water right now, it takes a lot of energy, and that energy, the biggest source of energy we have to do that is by burning fossil fuels. So right now it's not sustainable. But if we can split this water using renewable energy sources, and right now we don't have enough, or we can make hydrogen gas another way. Algae is another one that they're looking at, because some algae can be bred to create hydrogen gas. So that is one that people are looking at as well. So this would be an alternate for transportation. So as we decline in oil production around the world, we can use hydrogen to run cars. Now there are cars running on hydrogen right now. They are out there. There's just a few. They're usually experimental. They belong to car companies or universities that are experimenting with it, engineering programs. So they're considered experimental cars. And you have electrolysis of water, H2 gas, and oxygen gas. The O2 just goes off into the atmosphere, and then we burn H2. The problem right now is that we have these cars, again, that are being prototyped, but the problem right now is that we're using fossil fuels to split the water. No human health problems, and many countries and car companies and places are experimenting with it. But again, this is not going to work unless we find a source to make the hydrogen that is a sustainable source. And that's it.